Very good morning, children.
Good
Good morning,
morning,
sir.
sir.
Good
Good
morning.
morning, sir.
So, as a part of our learning, yesterday we learned the part one of which chapter?
Electric current.
Electric current. So, let me have a brief idea about them. So, what we studied? Can you say orally? So, these things we learned. Can
Electric
you?
current. Resistance. Ohm's law.
Yeah. Super. What more we learned? I think this is what we learned. So, what is meant by electric currents and which is basic conductors, which are not good conductors? Also, we studied, and we also said the ceramics can block the flow of electricity, and a few things will allow. And this kind of example is for what? Short circuit. Am I right?
Yes, sir.
And what is the
Yes,
formula
sir.
of electric current? I is equal to
Q
Q
by T.
by T.
Q by T, where Q is
Q
charge,
by
T
T.
for time, and this is
Time.
how a conductor can conduct electricity. And electric current is a what type of quantity? Vector or scalar?
Scalar.
Scalar. How to judge means you see here the current
Scalar.
whenever it is I naught, it splits into I1 and I2, and the total current can be taken as I naught is equal to I1 plus I2. But we don't apply their resultant formula called parallelogram law, because electric current, even though it is having direction, it does not obey the laws of vector addition. Means parallelogram law, it does not obey. This is what are these three examples we studied yesterday? Means the
So
purpose.
both two are open circuit and last one is closed circuit.
Two open circuits, one closed circuit. Okay. So in the first one, wire is not connected. In second one, battery only is not connected. What are these two instruments?
Ammeter.
Ammeter,
Ammeter.
galvanometer. Both
Galvanometer.
are used to measure electric currents. So this is the
Electric
formula of
current.
what? The basic electric current. I is equal to Q by E. This is potential difference we come across. What is the potential difference formula? V is equal to E by Q or W by Q. Joule per coulomb is called what? Children? Joule per coulomb is called what?
Volt.
Volt.
Volt. So what is the difference between EMF and potential difference? You'll get to know. So these are the foundation matters we need to go. Ohm's law. At a constant temperature, the current passing through a conductor is directly proportional to the potential difference. I proportional to V, V is equal to I R. And we are also studied ohmic conductors, non-ohmic conductors also. So these are the factors affecting resistance. Resistance is directly proportional to length and inversely proportional to area of cross section.
Area of
Area.
cross section.
You see the red color one, third point, fourth point. Resistance depends upon
Temperature.
temperature, and in fourth, it also depends on
Material.
material. Very good, Nana. Very good. So, what is meant by specific resistance and what is its SI unit? Ohm into meter. And reciprocal of resistance is called conductance, and reciprocal of resistivity is called conductivity. In our last class, this is what combination of resistors we learned. When three resistors are joined in series, as shown in the figure, what is the net resistance beta? Anyone? Anyone?
R1 plus R2 plus R.
Very good beta. R1 plus R2 plus R3. Now, in case of parallel combination, the one who is not answering.
1
R
by
is equals
R1
to
plus
1 by R1
R.
plus 1 by R2 plus 1 by R3.
Very good beta. So, I think this is what yesterday we learned. Now, today's concept is, what is the today's concept beta?
Heating effect of electric current.
Super. Heating effects of electric current. So whenever the charge is flowing, what happens? You see the down, that's what I was arranged a bulb. The filament, what happens to that filament? Whenever you're supplying the electricity, the filament will be heated up or cooled?
Heated.
Heated up. So due to that heating effects, will you get light? Am I right, children? When a
Yes.
electricity is supplied to the filament, filament will be heated up and that produces a light energy. It's a one type of conversion of energy beta. So these are all due to the flow of charge, because this chapter specifically talking about the charges which are in at rest or in motion. This chapter
Motion.
in motion. Very good, beta. Chakrika, very good. So what is the first one? It is Joule's
Joul's
law.
law.
Yeah. Actually, Joule's law, before we are going to talk about Joule's law, one must have to know about electric potential definition, what we learned yesterday. Children, please remember all formulas better. See here, uh, we know the formula of I as Q by T, and we know the formula as V is equal to W by Q, work done per unit charge. Once again, light beta. What is V formula, Nana?
W by Q.
W
W
by
by Q. And we studied I is equal to, just now we come across Q by
Q by T.
T. From this, what is Q? Cross multiply.
I into T.
I into T. And here, what is W? V into
VQ.
V. So, if I borrowed Q value from the left hand side formula, what is Q? In place of Q, I can write as
IT.
IT. So, therefore, the work done can be taken as in terms of electricity terms as voltage, current multiplied with time. Okay. Can you repeat? Anyone? How we taken two basic formulas. One basic formula is from, I expect it from Chakrika. Can you explain better?
We know that potential difference formula is V is equals to W by Q,
Very
and
good.
electric current formula is Q by T. From that, we obtain Q is equals to I into T, and from potential difference formula, we obtain W is equals to VQ. We
Good.
substitute Q is equals to IT and W is equals to VQ. Therefore, we get W is equals to VIT.
Yeah. In order to remember better, for my knowledge, I am giving to you as what you remember. Q is income tax, I into T, and W as Vivekananda Institute of Technology, VIT. Is it okay, beta? Right. So same W, in absence of electric field, your W will become H. Your W will become H. So W is amount of work done, H is amount of heat produced. For the both, the formulas is V I T.
T.
So voltage, current multiplied with time. Now here Ohm's law. What is Ohm's law? Amulya, V is equal to from Ohm's law. What is the formula of Ohm's law, Amulya? V is equal to I R. Lakshita?
Yes, sir.
Yeah. What is the work done formula? Just now we come across from Joule's law. W is equal to V
Q.
I
Sorry. V
T.
by T.
You are right, VQ, but Q can be written as I into T. So in place of V, if I substitute Ohm's law, what happens, Nana? I into R into I into T. Am I right, Nana?
Yes.
I into I will become.
I square.
So the formula will come as I square
I
RT.
square RT.
Okay. So what is the formula of now? Finally, the amount of heat is I square RT. The amount of heat produced is directly proportional to square of current. Accepted, children? Just now in formula we got no better. And
Yes,
which
sir.
also depends on resistance of the circuit. Finally, time of flow. So nothing but amount of heat is proportional to I square. H is proportional to R. Finally, H is proportional to T. So their proportionality constant is 1. So finally, we get it as H is equal to I square R T. What is I? Lakshita, what is I? Lakshita, Chakrika,
Yes, sir.
you quickly
Electric
reply,
current.
Amma. You are three only, no? You should be interact more. What is I?
Electric current.
Good. What is Kepler?
Resistance.
Resistance. What is small t?
Time.
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 All three are there. Three must be interactive. Amulya, keep your audio on. See this formula. Can you read a question, anyone?
Find the heat energy produced in a resistance of 10 ohm when 5A current flows through it for 5 minutes.
Yeah, 5A, 5 amperes. How to read it? 5 amperes current flows through it for 5 minutes. So the formula is H is equal to I square
I square
R.
RT.
RT.
I they given 5, they substituted 5 square into resistance 10. Time is how many minutes? 5 minutes.
5.
That
5
must be
minutes.
converted into seconds. So 5 into
300 seconds.
5 into 60 will give you 300. Very good. So totally you get what? I square RT value as 25 into 10 into 300. So we got here 75,000 joules. But they written as 75 kJ. What is K represents over there?
Kilojoules.
Kilos.
Kilojoules. Do you understand how they asked numerically these questions on this formula?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Yeah. After work by time is called what? Power. The rate of doing work is called what, beta? Power.
Uh,
Power.
So here the rate of doing electric work is called electric power. So electric power formula is work by time. They given here in the red color you see energy transferred by time they given this one. So that is divided by beta. Observe carefully. Energy transfer nothing but work. Then electric power is measured in watts.
watts.
And electric energy is measured in joules. And
Joule.
Joules.
time is measured in
Seconds.
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 seconds. 1 kilowatt, how many watts?
1000 watts.
1000
1000
watts.
watts.
1000 watts. 1 megawatt, how many watts?
10
10
lakh
power
watts.
6. 1 megawatt is nothing but 10 power 6 watts. Observe right side beta. What did you observe? Means generally the electric appliances given in our home or whatever we purchase are you able to see it? The maximum you may made. They're always shown an electrical device along with voltage and frequency requirements. What does that indicates? First line is what? 1650 hyphen 1960 W. What does it indicate? This indicates what? Children, are you able to see? If you want, I'll show you. W is a unit of what? W is a unit of what? Which one?
Electric power.
Electric.
Power. This is power. This, what is this in picture? May I know what is this electric device?
Iron.
Electric iron, you can also call press. Electric press. So this electric iron, which will use a power in between 1650 to 1960 watts, that much power it consumes. And down voltage is given, you see, 220 volts to 230 volts.
230.
and works under a frequency of 50 hertz to 60
60
hertz.
hertz.
Out of these three beta, first one indicating power and second one
Power.
indicating voltage
Energy.
and third one indicates what? Frequency. First one indicate what?
Power.
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 Power. Second one indicate what?
Energy.
Voltage. Third one indicate what?
Voltage.
Frequency.
Frequency.
Okay, very good, beta. Now, nearby you, any electric appliance is there out of you three? Can you get any electric appliance, beta? Hello, children. Can you get any electric appliance nearby you now? Say sir, no.
Yes, sir.
Yeah, get one electric appliance because we want to go with the practical. You have to know what is the power which is consumed and how much voltage it works, and if probably they will the frequency. Can you show to us? Make it fast. Amulya, Akshita. First turn on your video. Chakri, you get it better. Yeah. See the Chakrika got. Can you show? Yes, the same iron press. She brought very good beta. What is written? Because we cannot see it very clearly. We'll pin it. Just read and say. How much power it consumes?
1000 watts.
Yeah, 1000 watt power consumption. Very good beta. Next.
240 voltage.
240 volts. Very good. 50 to 60 hertz it is given.
Yes, sir.
Same. Good beta. There is a reason of asking you to get your own one. The reason behind of that is beta. Normal, the voltage range in our India is domestic purpose, household purpose is 230 to 240 volts. This is the range. And the frequency range also they ask in CBSE, what is the range of frequency in India for electric supply? 50 to 60 hertz only. Okay, now 50 to 60 hertz frequency is common and domestic purpose 240 volts is common. But the 1000 watts is different. Again, when you see the refrigerator, you will get a new value of power consumption. But voltage and frequency remain same. Voltage is around 240 volts and frequency is around
50 to
60 hertz. Around means you said the maximum value. Amulya, are not interacting. Are you there?
Yes, sir.
Be strong and interact. I'm not listening your voice today. So may I think you are there or not?
Yes, sir.
Now come back to our class. Are you able to see the screen, Nana?
Yes,
Yes, sir.
sir.
Yeah, the same one. Once again, I want anybody to explain. Joule's law strictly speaks about what? Heating effects of
electric current.
Electric
electric current.
current.
Can you read that yellow colored, shaded one, highlighted one?
The amount of work done in converting electric energy into heat energy is called Joule heating effect.
So the work done. Suppose when we rub two hands, now it is a winter, we'll do it. The purpose of rubbing these two hands, what it produces?
Heat.
Heat. We are doing work mechanically that produces heat. But instead of mechanical work, if it is done by electrical, then that is called heating effects of electric current. So thereby, I expect Amulya, can you read? W is equal to
V into Q.
V into Q. Next step,
W is equals to V into I into T.
V into I into T. Next,
W is equals to I into R
mm,
into I into T
mm,
is equals to I square R into T.
mm.
W is equals to V into V by R into
Mm.
T is equals
Very
to
good.
V square T
Okay.
by R.
Yeah, V square into T by R. Reading very good. So by this, what is the conclusions? What are the factors which is affecting the amount of heat? I denoted with Q, but in future I think they will denote it with capital H beta. Either you can use H or you can use capital Q. Children, can you read this? What are the factors will affect amount of heat?
Resistance, time, and electric current.
Yeah, can you read it like Q proportional to
I square Q proportional to R, Q proportional to
T?
time.
Q proportional to I square, Q proportional to R, Q proportional to
T.
T.
T. Just a minute, guys. Just a minute. Yeah. The next word is there. Yeah, fine. Next. What is this? This also we studied. Electrical energy. What is the green color shaded one? Highlighted one at least. Are you listening my voice?
Yes, sir.
Yeah. I want it from Lakshita.
The amount of work done maintaining the current in an electric circuit for a given time is called electrical energy.
Yeah. In a given time, how much of energy if it is maintained or how much of work it is doing, that can be measured as in terms of electrical energy. And the W formula is VIT, I square RT, V square T by R. From previous I copied. And mostly this energy we calculate in terms of watt hour. If you see that yellow color highlighted one, the amount of energy absorbed by an electric appliance in an hour is called watt hour. Means any appliance you take, electric plus refrigerator, TV, fan, tube light, in 1 hour, how much energy they consume, if you calculate, that is called watt hour. And I wrote there kilowatt hour. So what is mean by kilowatt hour? So 1 kilowatt hour, if I want to take better, kilo means how much?
1000 watt.
1000 watt hour. But I want in seconds, not in hours. 1 hour, how many seconds better?
36.
3600 watt second. Then you can write it as 36 after how many zeros are there? 36 into 10 raised to 5 watt second is called joule. So to write like this, I can make 3.6 into 10 power.
6 joules.
So therefore, 1 kilowatt hour, how many joules? 3.6 into
10 to the power of 6
10 power
joules.
6. Most important. From there only, the rate of electric work done is called electric power. The rate of electric work done is called electric power. And as usually, 1 kilowatt, how many watts? 1
1000
kilowatt. 1000 watts, 10 power 3. You please try to habituate for 10 power 3. And 1 megawatt,
10 power 6 watt.
10 power 6 watts. 1 horsepower, how many watts?
7.
746
740.
watts.
746 watts. Therefore, these are the some multiple conversions, but sub multiple conversions. Power formula, work by time. VIT, Vivekananda Institute of Technology by time. Time get cancelled. We get electric power is a product of voltage and electric power is a product of voltage and current. Am I right, children? Electric power is defined as the product of voltage and current. Then what is the power formula? If you substitute V is equal to IR, we get one formula. If you substitute I is equal to V by R, we get one more formula. How? See, I'll show you. P is equal to substitute in case of V, if we substitute IR, IR into I will become I square R. Am I right, children?
Yes,
Yes.
sir.
Next one. If you substitute in place of I as V by R, will become
V square by
E square by R. So there are two formulas. The purpose of writing that formula is, in first formula, power is directly proportional to the resistance. In second formula, the power is inversely proportional to the resistance. Okay, now? So this
Yes,
is
sir.
the formula which we used for power transmission beta. P is equal to V square by R. By keeping more voltage, when voltage is more, resistance is less, and power is also more.
less.
less.
More beta.
More
Because
what?
if
More.
resistance is less, power will be more, no beta. So that's what power transmission will become more easier. For any point of power production, if they wanted to transfer the power, they will take in terms of voltage constant. And remember, I forgot to say, when to use these formulas means P is equal to I square R, where current is constant, you have to use this one. And P is equal to V square by R, where voltage is constant, you have to use this one. So during the time of power transmission, what they keep constant? Voltage. That's what in your street. Have you ever seen the transformers beta?
Yes, sir.
Yes, sir.
Yes.
The street transformer contains voltage. You see, 11,000 volts or 10,000 volts danger. A board will be kept there. Have you read that board? Danger, 10,000 volts.
Yes, sir.
The reason of keeping, they'll keep voltage constant, by thereby resistance will become less and power will become more. So this
Hmm.
is what heating effects of electric current. Till now, all totally it is numerical part beta. Numerical part. So can we have a practice zone here? Yes. Come across here. Just quickly recall your formula and I'll just say which one. I think, is it visible to you beta? The one red color which I wrote.
Yes, sir.
Okay. Or maroon. Which one is better you see? Maroon or red? Quick.
Red.
Red. Then fine. First one is what? Calculate the power of a light bulb that uses how many joules? That means they're given what? Joules in the sense means they're given work. Work has how many joules? 1800 joules. And what is the time
18,
they given?
90.
90 seconds.
90 seconds. So what is the formula for power beta? Power, rate of doing work. Work by time.
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 So substitution please. So
20.
20 W.
20
What indicates W? 20
watts.
watts.
What?
I think the right side one can anybody? What is given? Now here they want energy. Work. Formula is what? Work is equal to power into
Time.
time. Superb. What is power here? 3 kilowatts. Means can I read this? Am I right, children? 3 kilowatts. And
Yes.
One
time is given.
60 seconds.
6.
1 hour, not 1 minute, beta. 1 hour. So an hour, 60 minutes. Sorry, 1 minute, 60 seconds. An hour, 3600, beta. So can anybody say what is 36 threes? 3 6 18. 1 remain. 3 3 is 9 plus 1. So 108 into 10 power
5
5
joules.
joules. Is these two problems are clear, beta?
Yes, sir.
Yes, sir.
Both are we are doing at work. One is power is work by time. Next time work is power into time. Yeah, fine.
Time.
Use the same knowledge. Now I don't intervene anything. I want this. What is the first answer? First, Lakshita. Lakshita, you say what we need to do. I'll keep an arrow mark. What process you have to do, you say. After that, we write the value over there. What they asked?
Sir,
I
that
kept
is
an arrow. Electrical power. How to get power formula? Quick beta, we are in online class. Come on. Power.
W into T.
W into T is energy. What is it previously? Power. This one.
Sir, W by T, W by T.
No confusion. Work by time. What is work they given?
600 joules.
By time.
20.
So, what is the answer? Final answer.
30.
30. 30 W watts. Very good. Chakrika, next one. This one.
Sir, power they given, time they given, no? They're asking W.
So,
W is equals to P into T.
good. So, power is 500.
500.
Hmm.
That is
15 by
75
75 double 0.
W.
Yeah, this one I expected from Amulya. Amulya, respond. This is the base formula what we are doing. Power is equal to work by time. Now they ask time. Time means work by power. Amulya,
Power.
respond Amulya. What is work they given? Chakrika, you only respond better.
Sir, they given power. They given W. They're asking to find time. W by P.
W by P. That means 800 by 20. The answer is
40.
40 seconds. You should say the unit also better. The last one, who will try? Lakshita or Chakrika?
Sure.
Yeah, Chakrika. Very good. Better.
60 kilojoules means 60 into 1000
Very good.
by 10 minutes means 600 seconds.
Okay, can I write like 10 into 60?
Yes, sir.
So that the cancellation will become easy. Now, what is the final answer?
600
Super better.
watt.
600 watt. Is this clear? Do you understand? Shall I go ahead?
Yes, sir.
Yes, sir.
Amulya, I want your audio to work. Why you're not responding? Amulya,
Sir.
I want your audio. Understand?
Yes, sir. Okay.
Under any circumstances, you don't miss your audio better.
Okay, sir.
Done. Now it's Amulya turn only. Amulya, respond better. Are you seeing what I given? Give the formula for each. What is the formula for Ohm's law? Amulya?
V is equals to I into R.
Super better. Next. Chakrika, what is the formula for resistance in terms of length, area, resistivity? You remember? R is equal to?
Yes, sir, I remember. R
Then
is
tell me.
equals to rho L by
Superb, Nana. R is equal to rho L by A. Now next question. Current in terms of voltage and resistance means same in terms of Ohm law only. I is equal to?
V by R.
V by R. Very good, Nana. I think this is Lakshita can do it. Only two resistors you take better. Equivalent resistance of resistors in series. R net is equal to only two resistors are there means?
R1 plus R2.
Very good.
R1 plus R2.
In case of parallel,
1 by
1
R
by
square.
1 by
R net.
R1.
1
R1
by.
1
plus
by
R2.
R1
R1
plus
plus
1 by
R1
R2.
plus 1 by R2.
R2.
So finally, just now we come a power produced in the resistance. P is equal to power formula. V square by.
R.
R.
Okay, quickly, Chakrika, can you read all formulas? Only formulas. V is equal to. Read only the right side formulas.
IR.
Ah,
V is equals to IR.
hmm,
R is equals to rho L by A. I is
very good.
equals to V by R. R net is equals to R1 plus R2. 1 by
Hmm,
R net is equals to 1 by
hmm,
R1 plus 1 by R2. P is equals to V squared by R.
very good. Yeah. So this is what the formulas we learned in electric current vector. Now let me try to do this problem. A wire of length 3 meters and area of cross section 1.7 into 10 power minus 6 meters square has a resistance 3 into 10 power minus 2 ohms. So your first question is, what is the formula for resistivity? So part A, what is the formula of resistivity? R is equal to, just now we come across.
Rho L by A.
Superb, Nana. Rho L by A.
L by
Rho
A.
is equals to
Rho
RA
is
by
equals
L.
to R
They
A
asked
by L.
resistivity, yeah? Okay,
Yes,
thank
sir.
you. Rho is equal to R A by L.
L.
Substitution, please, Chakrika. What is R? Resistance. 3 into.
10 power minus 2
Very good. Area.
into
3 into 10 power
1.7 into
minus
You are giving delay answers
1.7 into 10
by
power
length.
minus 2.
3.
So 3 3 get
3.
cancelled
3.
better. What do you get, Rho? 1.7
7
into.
into 10 power minus 8.
And the
To the
special
power
unit
of
is what?
minus
Ohm
8.
Ohm
into
meter.
meter. This problem, do you understand? Ohm into meter. This
Yes,
is
sir.
what SCBSE with how they are asking these questions better. The
Yes.
final answer is what? Resistivity of the wire 1.7 into 10 raised to minus 8 ohm into meter. Next question. So try to understand the question. These are just made to understand how the questions will be asked in exam. There are how many resistors are there?
M.
Hmm. Small m number of
M.
resistors are there. Each resistance, capital R. First of all, they're all connected in
R.
Series.
series. And that time the equal resistance is they given
X.
X. And now they are connected in,
Is X.
now they
Parallel.
are connected in parallel. And its equal resistance is
Y.
Y.
Parallel.
And we need to find
Parallel.
what is the ratio of Xn.
1.
Equivalent resistance. Y.
Y.
See children,
X and Y.
let us take, if they are in series, they called X, no? X is equal to, suppose if n resistors are added in series or m resistors are added in series, R plus R plus R plus R all same, no? What you can write? M into R. Am I right, children? You multiply with M into R. Means, my meaning is 2 ohm, 2 ohm, 2 ohm added in series. Total 2 plus 2 plus 2. What is the answer? 2 plus 2 plus 2 addition 6.
6.
6.
The same 6 can be written as 2 into 3.
Yes.
Yes.
So here M are there. So that's what I wrote M into R. Similarly, if they are connected in parallel, the net resistance is Y. Y is equal to, in case of parallel, we should divide
R by.
R by M. So now what they want better? The ratio between X and Y. Can you say now it
Y.
is X
Y.
by Y?
Equals
X
to
by Y is equals to
R by.
And
MR into by
R
R
by
by
M.
M.
R.
Any cancellations?
R. R.
R by
Super. RR cancel this M into
M
M.
square.
So the finally ratio of X and Y is M square
M
is 2.
square is to 1.
1.
Okay,
M
here they
square
take
is
an
to
M.
1.
If I take N, small n, answer.
N
N
square is
square is
to
to 1.
If I take small p,
P square is to 1.
3.
p square is to 1. Means
Square
number
is
of
2.
resistances you need to square by 1. Will give you the series equivalent and as well as parallel equivalent. Shall I go ahead better?
Yes, sir.
Yes.
Okay. So in series, M into R. In parallel, R by
M.
M. Yeah, here. So what is given? There
Alright.
are four resistors it seems. A as well as B, C and D. And the values also they given. This is 4 ohms. Good. This is 8 ohms. This is
8, 12, 24.
what is the question?
Lower resistance which can be obtained by combining these
Yeah, there are two
resistors.
questions better. One is to find the lowest resistance in which all fours to be used. Am I right, children?
Yes, sir.
Yes. And next we want highest resistance that can be obtained by combining this again four. So when do you get resistance is high? When they joined in series or parallel?
Joined in series.
Series. So series means what you should do? Add them all. 4 plus.
8 plus 12 plus 24. 48.
So super better. What is the highest resistance we obtain?
48.
Ohms. But
48.
how do you join them to get lowest resistance? They must be in super nana.
Parallel.
Parallel means 1 by 4 plus.
1 by 8 plus
12
1
plus
by
1 by
12 plus
24.
1 by 24
So I think 24 is
equals
final
to
LCM. 4 6 are 8 3s are. Am I right, children?
Yes,
12
sir.
2s are 1.
6.
So how much you get? 6 plus 3 9 11
12 by
12.
24.
12 by 24. But we should take what? 24 by 12. Reason? We want RP. So therefore, RP is equal to 24 by 12. The answer is
2.
24 by 12.
2.
2 ohms. Okay, quickly anybody say? I expect it from Lakshtar Amulya. How do you get
Sir,
lowest distance?
lowest resistance are in the parallel series. So
Lowest resistance means we should connect them all in parallel.
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 How do you get
So
highest
we have
resistance?
joined the series.
So join them in series. Is this clear?
Yes,
Yes,
sir.
sir.
Good. Now this one. How can three resistors of 2 ohm, 3 ohm and 6 ohm are connected to give a total resistance of 4 ohm and as well as 1 ohm? First we try to get for 4 ohm.
4 ohm.
Suppose 2 ohm is like this and if I joined, if this is, and you can try this one in various trial and error method. This is 3 ohms, this is 6 ohms. How the 6 and 3 beta? So net resistance is equal to
Parallel.
parallel. This is 2 plus as 3 parallel with 6. 2 plus we can write like this also. 3 is parallel with 6. How much answer? Here I can write 6 into 3 by 6 plus 3. Yesterday we did this one. 18 by 9. What is the answer beta? 2. So
2.
therefore it gives
4 ohm.
4
4.
ohms. Now what is B? We need to obtain
1 ohm.
1 ohm. How do you get 1 ohm? I am thinking all three you connect them in.
Parallel.
Super idea, beta. Super. Very good. 6 ohm, 3 ohm, and as well as 2
2
ohm.
ohm.
How to find the parallel resistance, beta?
1 by R is equals to 1
1
by
by
R
R
one plus
equals
1 by
Yeah,
R2 plus
1
1.
by 1 by R is equal to 1 by 2 plus 1 by 3 plus 1 by.
6.
Here also LCM is 6.
2 plus 3 plus 1 by 6.
Yeah, 2 plus super better. 3 plus 1.
6 by 6.
6 by 6. Luckily, R is
Yeah.
1. So, like this, we can calculate how did they ask in the examinations. Is it clear till now, beta?
Yes, sir.
This is what we learned today. We learn formulas, we learn what are the heating effects, what is Joule's law, what is work done, how do you calculate electric power, and how an electric consumption can be taken. Understand? Can quickly you can say what you learn? Small electric energy, electric power, and some numericals. Did you get some idea, beta?
Yes, sir.
Yes. Where is Chakrika?